Okay, so in example one, this is one of our first quadratic applications. We're given that a farmer wishes to enclose a rectangular region using 120 feet of fencing. He doesn't need all four sides fenced in because he's going to use the barn as one side of the enclosure. So again, the first job would be to just sketch a quick graph of this. So we'll use this to be the barn, and then he will use fencing on three sides to form the pen. Okay. We're given variables to use and told which side will be that. So it says determine a function A. Oh, sorry. Let x represent the length of one of the parallel sides. So again, remember, there's only three sides. The parallel sides are what we're calling x. Okay. Now the first thing we should do is figure out what this side should be. Okay. Well, the key is obviously we only have 120 feet of fencing. We used up x over here and x over here, so we've already used up 2x. So whatever is left from the 120 will be how long this third side is. Okay, so now we have the length and width, if you want, of the rectangle. So for part A, we're asked to determine the function that represents area based on x. So once I plug in x, right, area is x times length times width, x times 120 minus 2x. Okay. Again, it's kind of important to realize that this is a function of x. So once you know how long this side is, so I'm just going to give you an example here. Let's suppose x is 10. Well, then we know the other side is 10. So we've already used up 20 feet of fencing. So we have 100 feet left for this third side. Now notice that does not fit into the function. That's just buried in here. So if x is 10, the other side turns out to be 100. 10 times 100 is 1,000. Okay, so just remember that this long side here, 120 minus 2x, is sort of buried in the function. The function takes how long this side is, the parallel sides, and spits out the area. Okay. So with the restrictions on x, right, x is how long a side is, so it certainly has to be positive. Okay. There is a limit, right, because we only have 120 feet of fencing. Now, we can't say 120, right, because if this side's 120, that's nothing left for the other two sides. Okay, so whatever we use here, we have to use here. So that immediately cuts it in half, so we can go down to 60. Okay, but again, if this side's 60 and this side is 60, we have nothing left. We won't have a rectangle. Anything less than 60, though, will be okay. Okay, so even 59, even though it will be oddly shaped, you get a 59 here, 59 here, and that leaves 2 feet left over for that. Okay, but it has to be less than 60. Okay. For part C, we graph the function. So we just grab our calculator here. All right, we type in our function. So we have x times 120 minus 2x. Try to move this down a little bit. That's not working so well. Hopefully you can see that. Now, window's a little tricky because of the applications we don't typically have. We don't want to use the standard window. Okay. Now, fortunately, we in part B had already figured out the range or the domain 0 to 60. So if you first look at my window, you'll see the first thing I have is x min and max to be 60. I'm just counting by tens. Okay. For y, now remember the y is the output, so that's the area. Okay, so the area is going to be positive. So the first thing I have is y min will be 0. The max is a little bit trickier because we don't really know how big it'll get. But just with the one value I put in, I got an area of 1,000. Okay, so I'm guessing it could go bigger than that, so I guessed 3,000. Okay, counting by 500ths. Okay, so if I graph, we're not surprised to see a parabola. Remember, if you distribute this out, you'll get a quadratic. Okay, and seem to have a pretty good picture of it. Okay, first, so then part D says what does the point 18, 15, 12 represent? Okay, so again, you can find that on your calculator. Remember, that's just calculating the value. So that's number 1. Plug in 18. Apparently, we get 15, 12 out. Okay. So what does that mean? Well, remember, input is x. So x equals 18. Remember, that's the length of each of the two parallel sides. And then the output, a of x, or a of 18, to be 15, 12. Remember, that's the area of the rectangle. Okay. Now, keep in mind, what's not given, right? We have input, we have output. is how long this other side is. But remember, that's something you can just figure it out on your own. So again, we have another example. Well, what if x is 18? Okay. Well, then if we take, I'll just do this in my calculator real quick, right? 120 minus 2 times 18. I guess I could show you that. So 120 minus 2 times 18 gives us a side of 84. So if I have 18 for each of the two sides here, then that'll leave 84 here, and 18 by 84 rectangle gives me that area of 1512. Okay. All right, and then finally, you're asked to find the maximum area. Okay, well again, we had a nice parabola. The output, which is the y values here, is maximized right here at the vertex of your parabola. So I'll just use my calculator to calculate the maximum. Okay, so we hit enter. And we're going to ask you for a left or lower bound. Well, we're already left of the vertex. We'll arrow over to the right side. Hit enter, and then you have to put in your guess. And I hit enter again. And it gives me, I'll round that off to 30 comma 1800. Okay, so the maximum point, which is our vertex, is 30 comma 1800. So remember, that would be a side x of 30, which gives you an area of 1800. Okay, so again, our question was the maximum area. So that for us, the maximum area is 1800. Again, how did we get that? Well, again, we had already done a couple of these. We got up to 1512, but if we make one side 30, remember that would be 30 and 30, so that's 60, so it leaves 60 left over, so that would result in a 30 by 60 rectangle. So the area would be 1800.